Hello guys, welcome back to a new tutorial. Today we are back in the Pokemon Go series, and today we're going to be going over the GPS system. So we're going to be using Unity's built-in GPS system with the latitude and longitude, and we're going to be basically just controlling that. The next tutorial, we're going to be doing athletics for this, so like the athletics and all that, so the looks basically. And yeah, so that's going to be what we're doing in this tutorial. So let's go ahead and get right into it. Okay, so first thing you want to do is to delete this cube here. So this cube was what we were using to open up our Pokemon scene, our catching scene. So we're going to go and delete that cube. And we're going to add let's just do a capsule. That works just fine. This is going to be our player for right now. And we're going to add a new script on this guy called GPS system. Open that script up. Okay, so once it opens up, you want to go ahead and delete all of the functions in here. We're not going to be using a lot of these. We're going to be using the start function, but we're going to get to that in a second. Okay, so we're going to need to implement the UI. So we need to say using Unity engine.ui. And then another thing we need to implement is Unity engine.scene management. There we go. So once you implement both of those, we can start creating our variables. First variable will be a vector2, and it will be in real life init, so R init. We need to create another vector2 that is called our current position. So this is our real life current position on the longitude and latitude scale. We need to implement a vector2 f in it, so not implement, but create a variable f in it, and this is a fake world in it, and then our fake world current position. And we also need to create a float, so public float. And this will be our scale, and I'll get to what all these are in a second. And we'll also create a boolean called faking location. We'll also get to that in a second. Okay, so basically what these variables do is basically we're going to be taking the real world position and the fake position, and eventually we're going to be subtracting them and all that, just where we get a position of 0 at the end of it. And then that's also how we're going to be using our Pokestops. So let's go ahead and create a function, a start function. So public void start. There we go. In this start function, we need to say if, well, for now we're not going to have that. We're going to say input.location.start. So input.location.start. And inside these little parameters here, we're going to basically say 0.5. So basically, why do we say 0.5? Basically, this is how precise we want our map to be. So how precise is it going to be? In 0.5 meters is basically what that is. Now, another thing we need to do is enable the compass. So we need to say input.location.compass. Sorry, not location, input.compass .enabled equals true. And that's important just to make sure our compass and location and all that is on. Okay. And after that, we also need to set the f in it, so the fake in it, and that will be a vector of 0, so vector2 0. There we go. And that's pretty good right there, so that's alright. That'll work for now. And then we need an I enumerator, so basically a coroutine update position. This is where all of the magic happens. This is where we move. This is where we call the Pokestop eventually. That will be in the next tutorial, not this one. But this is basically where we do everything. So, first things first, we need to check to see if our location is enabled, because if it's not going to work, it's going to crash, and so we don't want it to crash. So basically we're going to do a couple of things to make sure our location is enabled, that way it doesn't crash. So first things first, we need to say if input.location is enabled by user equals, well, that'll work for now. Yeah, equals false. So if it is enabled by the user, then basically don't do anything. But if it's not enabled by the user, then basically we're going to fail. So this is going to fail if it's not enabled by the user. So let's go ahead and debug.log. We're going to change that soon, but not right now. And we're going to say failed because user did not enable location. There we go. And after that, we're going to say int max wait. So basically, why are we saying this? Why do we even need this variable here? Basically, this is how long we're going to wait to get the location. So if it is on, then basically, how long are we going to wait to see if it's on? So if it's on, but we just don't have internet, or if we don't have Wi-Fi or something like that, then it's obviously not going to work. So we're going to wait 20 seconds, and if it's still not on by the time that 20 seconds is over, then just fail. So we're going to say while input.location.status equals location service status dot initializing. So while it's initializing, and in max wait is greater than 0. And after that, you're just going to yield, return, do wait for seconds. And we're just going to wait 1 second. And then we're going to say max wait. And we're just going to subtract max wait. And after that, you're going to say if max wait is less than 1, then we need to fail. So we're going to say debug.log initializing failed. Try again. So basically, we're going to have to open the app and close it, open, and all that. And then we're going to say yield return null. So basically, if it failed, then just break out of the function. Okay. Next, we need to say if input dot location dot status equals location service status. So we're going to basically do this again. Dot failed. So if it did fail, so if it's been initializing for over 20 seconds, so if we're just going to initialize for a while, then just fail, make it fail. But if it did fail, then we need to say debug.log failed location service status. So service status failed. So that's going to tell us if it failed or not. And then after that, you're going to say yield return null. So if it did fail, then just break out of the function. Yield return null. And after that, we can actually get into the position moving and all that. Now what you can say is set location, and this will be a function that we will create in just a second. And we're going to put some stuff in that in a second. But let's go ahead and create this function. So we're going to say void set location. And in here, we're going to have a float of latitude and a float of longitude. There we go. Now, in here, we need to say our current position, so our real life current position equals new vector2 latitude and longitude. There we go. And next, we'll just say vector2, and we're creating a vector2, and this vector2 will be called delta. And this will be set to a new vector2 of our current position, so our real life current position on the x-axis minus our r, so our real life init dot x. And then basically we're just going to do the same thing over here, except this time we're going to be doing it on the y-axis. There we go. And that's pretty good right there. So that's our delta. And this delta is very important. Now we need to set our fake current position. And this current position will be delta times scale. Now, why do we need this scale here? So basically, our longitude and latitude it moves by a very little percentage. So if I move miles and miles to the right, then it's only going to move by a couple of decimal points, basically. So it'll be like 1.00001. I move 5 miles, and it's going to be 1.00001. So from 1, it went to 0.1 type of thing. So it moves by a very little percentage, and that's not good. So we need to multiply it by scale, and our scale will be a very large number, like 1,000. And that way we move on a bigger scale. So basically we're going to be zooming in, so to say. So now we just say this.transform.position equals new of vector 3. And we will set this to our fake current position dot x, and then we're going to set our y to 0, and then our fake current position dot y for our y-axis. And that works. So basically, this little function right here sets our location in our world. So it's always going to start from 0, and then from 0, we're going to move. So next, we need to basically set our location here. So when we say set location, how are we going to get our real longitude and latitude? Well, thankfully, Unity has it built into their system. So now we just say input dot location dot last data dot latitude, and then we can also do the same thing for the longitude. So input dot location dot last data dot longitude, and that works right there. So this is our very simple function to move in real life. So next, we're going to be doing our Pokestop in the next tutorial, as I said. But if we start from 0, then how do we get our Pokestop? So basically, to do that, we're going to basically be instantiating our Pokestop if our position is somewhat similar to where our Pokestop is in real life. And I already have that finished. I'm just going to be doing it in the next tutorial. So basically, we're just going to call our update position in our update function, because we're always going to be checking for that. So in our update, we're just going to start a coroutine, update position. There we go. And depending on your computer, it may crash, it may not. So if I play this, it won't crash. But what does happen is it failed because the user did not enable location. And that's obvious. Depending on your computer, it may crash because just different problems. But how do we test it on our computer? To do this, we need to use our faking location boolean. Now, we're going to enable a couple of things in here. So basically, we're going to, in our update position, we're going to say if faking location equals false, then we can do all of this. But otherwise, we're basically just going to say if faking location. So instead, we'll just add an else onto here. So else. And we're going to set the location to be 100 plus time dot time, and then 100 plus time dot time. And this basically allows us to test it in Unity without having to deploy it to our phone. Now, obviously, it obviously won't work exactly how you think it will, but just to see if this update position is calling, we need to just to see if set location works, we need to do this right here. So now if we play it, our capsule should not do anything, right? And the reason for that was because we've not even enabled faking location. Now that we do, you can see that our capsule is just constantly moving in that direction. And that's perfect. So, as you saw, we were moving by large amounts, very large amounts, in whatever direction we were going. So basically, that was probably over this way. So we were going very fast, which means that that this works. So this function works. Now you can test it on a phone or a Android device or an Apple device. One last thing we need to do, though, before we test it, is to see, well, as you can see here, our debug.log, it doesn't necessarily work on an Android phone. So let's say we wanted to do something like this. Let's just say we have UI here. So this is why we enabled UI, is to do this. So now we can add text. So let's add text. And we can move it up. And this will be the text that tells us if our location is failed or if our location has successed or succeeded. Let's make this a little bit larger. Now, if you're indoors and you can't really get outside at the moment, then what you can do is create another text object, and this will be our real position, not our real position, not our longitude and latitude, but our fake position in the world. So this capsule's position. So since we're starting at 0, 0, we can, since we're always starting at 0, 0, we can always see whether we're moving just by a little percentage or a big percentage, depending on how much we move. So to do this, all you need to do is go into Unity and obviously create that text object, and then you need to go into Visual Studio here, and I'm going to set the location. So right down here in our set location, we're going to say game object dot find, and we're going to find coordinate text. So we'll just do position text. And in here, we'll just say docket component. And we're going to get text dot text. So basically, we're getting our text of our UI, and we're just going to say this dot transform dot position dot x plus. There we go. And basically, you can just do the same thing dot y. And same thing for the z. Okay, now you can build it onto your phone. One last thing you will probably want to do is assign your camera to the capsule. So you can obviously build it right now if you want to. It's obviously working depending on if you did anything wrong or right. But this capsule right here, our camera is not completely focused on it. So if this capsule moves, the camera will not move with it, and therefore it may go out of our camera view depending on where your view scene thing is. Alright, so now we can take this main camera and drag it under the capsule. And that's pretty simple. That's right. And now if you position your capsule at 0, 0, 0, that is obviously where your position will be in game. So let's move this up here. Now, just to see if this does work, we'll move him way out here, and we know he will always come back to 0, 0 if it worked. So let's go ahead and test this by building it again. One other thing I forgot to mention to do is basically to go under set location. In real life, init needs to be set to our longitude and latitude. So basically, we can just set this to a new vector 2. And this will just be input dot location dot last data dot latitude and then longitude. one thing I forgot to mention, again, is that in this RNet thing, right above it, we need to add an if statement that says if RNet equals vector 2.0. Now, this is very important. There we go. Now you can test the game. As you can see, if you look really closely to those numbers, they are actually moving. So it's like, it started from 0, and then from 0, it moved me to a certain position. So as you just saw, that did work. We were moving around the scene and all that, and that was actually me walking it in real life. So that did work. Now, this still isn't Pokemon Go though, because you actually have to catch the Pokemon, and we're not doing that currently. So another thing I'm going to be doing is basically showing you guys how to spawn the Pokemon randomly throughout your world. So we're also going to add a new script, and this will be called spawn random Pokemon. And basically this will be controlled, this will control our spawning of all the Pokemon. So let's open it up, reload. And as you can see in our spawn Pokemon, we're basically instantiating anything that is in the resources.load. So basically, we're instantiating with the Pokemon. So in here, we're going to be spawning random Pokemon, right? So we need a list of all the Pokemon we can actually spawn. So currently, Unity does not know what a list is currently, so we need to implement using system.collections.generic. Okay, so now this list here, what is this list going to be? So this list will be a string of Pokemon that we can spawn. So Pokemon, that would be what the list is, and that equals new list string. There we go. And this needs to be a string over here. There we go. So that's our list. We will assign all of that in a little bit. Now, how are we going to spawn this Pokemon? So in our start function, what are we going to be doing? We're going to be calling this function. So a coroutine that we're about to make. So public enumerator, that'll be a coroutine spawn Pokemon. Now, what are we doing in here? So in here, we're going to say yield return new wait for seconds, and we're going to wait for random amount. So basically random dot range between, and we're basically just going to wait between. We'll do 0, and sometimes it's like 3 minutes. That's 4 minutes sometimes. So basically, we're going to do 340 seconds, and that is a pretty long time right there to wait, but that's okay. So now this is simple right here. So now, after we wait for that long, what are we going to do? We're going to spawn the Pokemon, right? So how do we do that? Now we need to spawn the model of the Pokemon we want. So basically, we're going to just instantiate a Pokemon prefab. So it's public game object Pokemon prefab. There we go. Now we're going to instantiate this Pokemon prefab at a certain position. So we're going to want to position this Pokemon at a random position in a radius between me and the end of the radius, basically. Okay, so in here we're just going to say random dot inside unit sphere, and we're just going to do like 5 or something like that. Okay, so for this vector, so basically where we're going to spawn it, we're just going to say random dot inside unit sphere times 5. And that should work. And then we're going to just say this.transform.rotation works just fine for now. Now, something else we need to do is basically say game objects Pokemon. So this would be our Pokemon spawned. So after we spawned our Pokemon. Alright. And then basically this would just be called Pokemon spawned. Whoop. We just need to say game object Pokemon spawned equals instantiate as game object. There we go. And we don't need this much for here. There we go. So now what we need to do is say Pokemon spawned dot get component, and we're gonna get the component of our thing here. So our Pokemon, our ID. So we need to say dot get component Pokemon dot, and we'll just say dot ID equals, and we're gonna get our list, so our Pokemon list, and in here we're just gonna say we're gonna get a random Pokemon to spawn basically. So we're gonna spawn a random Pokemon between the range of 0 and Pokemon dot length, not length dot count. Sorry about that. Dot count, not length. Okay, now that is simple right there. So that is basically what we want. So we're going to spawn a random Pokemon, right? Well, what happens if our game object is a Pidgey, but it picks like a Charmander or something? Well, that's going to be a problem. But thankfully, I know how to fix that. So to fix that, basically, we're going to go to our Pokemon ID thing here. So on start, so basically when we start the game, or when this guy spawns, so we just changed start from await. So basically, when our Pokemon spawns, what are we going to want to do? Basically, we're going to say whatever the ID is, spawn that Pokemon. That type of Pokemon. So what we can do is say instantiate, and we're going to instantiate a resources.load. So we're going to load, and then in here we're just going to load the ID. So basically the name of the Pokemon plus standing model, just so that works a little bit better. And then we're going to obviously instantiate it at this dot transform dot position and this dot transform dot rotation. There we go. That fixes our problem. Now in Unity, what do we need to do? Basically, we need to now create a new prefab called Pokemon standing. And on this, we need to add a Pokemon script. And then we also need to give it a box collider. And that should work right there. Now, in our script here, what we can say is when we instantiate this, obviously we instantiate it. But we need to also get the manager. So we need to say manager equals game object dot find, and we need to find the game object with the manager, and that game object is the manager here. So just get that right here, copy it. So we're going to get the manager, get component manager, Pokemon manager, sorry. There we go. Now we spawn this guy. Now, what if this is the case? So, well, Pokemon manager. There you go. Okay, now if this is the case right here, so if we're spawning things randomly inside a sphere according to amount of seconds, then no matter how much we move, we're not going to spawn anything, right? So we need to change this. So the more we move, the less time something has to spawn. So that's what we're going to do. It's not exactly like Pokemon Go, but it actually works. So depending on how much we move, this time right here will go down. So now we say public bool. It needs to be public, and it's not a bool, it's an integer time. And this time will go down every single second. So in our update, we need to basically subtract time. And we need to subtract it by time dot delta time. So basically subtract it by time dot delta time. Looks like this is a little bit of a problem. Time to wait works right there. So in here, we just change it to time to wait. And then let's say time dot delta time times, well, that'll work right there. Times 1. So basically, every single second, this is going to be, is basically going to subtract by 1. It should be changed to a float. There we go. Now, this is pretty simple right here. This actually works. But still, it's still not what we want. So the more we move, the more it subtracts. So basically, when we go to our GPS system, let's open that up right here. GPS system. Basically, we're going to say the more we move, so we're going to just basically, in our set location, basically we're going to say if this dot transform dot position equals the last transform dot position. So basically, we're going to get the position every few seconds. We're going to get the position, okay? So we're going to say public enumerator get old position, right? Okay, and basically every few seconds, so every few seconds we're going to get our old position. And if it's the same as our old position, then don't call set location. So every 3 seconds, we're going to get our old position. So we're going to have a private float, or actually private vector 3. That works. Old position. Now what we can do is say old position equals this dot transform dot position, right? Okay, now we need to say down here, if this dot transform dot position equals old position, then don't do this. So if it does not equal that, then do this. Instead of that, we'll just put that there. And there we go. Oh. Okay, so now that that's done, basically down here, the more we move, basically we're going to subtract the time of our Pokemon thing here, so of our spawn random Pokemon. So basically, we're just going to say this dot transform dot get component. Oh, this dot transform dot game object, or just this dot game object, whichever you prefer. Dot get component, and we're going to get the component of spawn random Pokemon. Now, in here, we can just say if, or instead of if, we're just going to subtract the time to wait by, let's just say, 4. And that should work. Now, that's pretty simple. Now, one thing that's a little bit of a flaw is that first, our transform position does not move. So basically, we need to be calling set location, but we need to be changing this. We need to change this, and we need to move it down here. So we need to always be moving. We just don't want to always be subtracting time. So if this position is the same as the old position, then don't subtract the time. But if we're moving, then subtract the time. That should work right there. Now in Unity, we can play this. So we're going to turn, for now, faking location will be fine. Now we need to assign the Pokemon standing prefab here. And time to wait will be 320 seconds. And our Pokemon, we only have a Pidgeot right now, so we need to set it to size 1. And Pidgeot. There we go. And then obviously the models in this thing. So we need to take the Pidgeot over here. We need to remove some of the stuff, so there we go. And now we can rename him to be Pidgeot Standing, and then we pull him into the prefabs, and that works just fine. Last thing, all this stuff looks fine. And it needs to be changed to, well, that should work. And now, if we play this, our time to wait obviously will be very little, or a lot, and we're not going to be moving, so we're going to be waiting for like forever. So we'll change this to 10 seconds, 4 seconds, 3 seconds, 2 seconds. And obviously it didn't really work, so when in our spawn Pokemon, when we wait, after the wait, we need to set the time to wait to be the same thing. So time to wait equals 320 right after. So at the end of this function here, let's change that real quick. At the end of the function, we're going to reset, basically. So we need to actually call this. So this didn't work because we're not calling it right now. So we need to basically constantly call this. So what we can do is just say spawn Pokemon. Well, we need to start the coroutine. And we're basically going to start the coroutine inside the coroutine. I know that that's not a good idea, but this will work for now. It's okay. So let's just start the coroutine inside the coroutine. And this should work just fine. Pokemon Standing clone. Now, as you see, it's Pidgeot, but Pidgeot, basically, down in our Pokemon thing, basically when we want to instantiate, we need to change this right here to be standing instead of standing model, because we don't have anything like that. Now when we play this, you just wait a couple of seconds. Pokemon Standing spawns, still is Pidgeot, and as you can see, we're constantly spawning them. But unfortunately, Pokemon Standing still does not exist. So Pidgeot Standing, so Pidgeot plus Standing, evidently does not exist, which is okay. So down here, if it's Pidgeot, let's actually play it and to see what's going on. Pokemon Standing, Pidgeot, so Pidgeot plus Standing should equal Pidgeot Standing, but unfortunately it's not spawning. So let's get right into seeing what the problem is. Let's go to our console. The object you want to instantiate is null. So when we resources.load, let's make sure we're doing this right. So resources.load, so Pidgeot Standing is right there. So ID plus Standing. Something that may be causing a problem. Manager.pokemon equals ID. That should well, instead of let's move this back down here. To fix this, all we need to do is create a coroutine. And we're going to call this coroutine spawn Pokemon. And basically, we're just going to wait for a second. So yield return new, wait for seconds, and we're going to wait a few seconds. So 2 seconds before actually spawning the Pokemon itself. And then we can instantiate the ID plus Standing. Now, what was the problem? The problem was that our GPS system, or spawn random Pokemon, was not setting the ID straight away. It was waiting a couple of seconds after it was trying to instantiate it, therefore the ID was nothing. Therefore, there was nothing called standing in the resources folder. So now if you play this, it should spawn him, but it will wait to instantiate until a few seconds after. So there we go, there's our Pidgeot right there. But as you can see, it doesn't necessarily work because he's up in the air. And that's a problem. Now to fix that, when we spawn the Pokemon, what we need to do is instead of spawning it inside a random sphere, say new vector 3 in here. Basically, we're going to spawn him in the basically in the random sphere on the X and the Y, but on the X and the Z, but on the Y axis, what we're going to do is basically we're going to set it to 0. So that way, they're both on the same plane. There we go. So as you can see here, we're going to spawn him, but we're going to spawn him only inside the random sphere on the Y, on the X and the Z, and on the Y, we're going to be setting it to 0. Therefore, he's not up in the air like he just was. So let's wait just a couple of seconds. And as you can see, he spawns on the same plane as we did. But he is gigantic, and obviously that's not what we want. So we need to change his model here. So let's delete both of those. Pidgeot standing is gigantic, as you can see. So we need to scale him down to be about the size we want him to be, and about that's probably good right there. Now we can apply this, and now we have a random spawning a Pokemon. So now if we play this and we wait a good while, you can see one spawned right over there. That's pretty cool. Now we'll wait a couple of seconds to see where the next one spawns. As you can see, the second Pokemon did not spawn. Basically, to fix this, all we need to do is constantly call this. So we are always wanting to try to spawn Pokemon. But basically, we're only going to do it a little bit at a time. There we go. That should work. Now when we play this, we should start spawning some Pokemon spawning, and as you can see, tons of them are spawning everywhere. Tons of Pidgeys. Your worst nightmare. But as you can see, it does work. Now one thing that will be nice to do is basically to go over here, and when we instantiate him, basically we just want him to be a child. So we're just going to say game object Pokemon Pokemon standing, actually. And basically, we're just going to say Pokemon standing equals instantiate as game object. Now, this should work just fine as long as we change Pokemon standing . There we go, and we need to change him, so we need to change his parent to be this game object. So this dot transform, and that should work. Now we play it, and everything should be a little bit cleaner, but also we see we have a bunch of them spawning everywhere. Now, why do we have them all spawning like everywhere? Well, this is something that that's pretty simple to explain. Basically, we're spawning them between 0 and 10 seconds. So we're almost spawning them every few seconds, and that's obviously not what you want. So time to wait would be around 320 seconds. And from there, you can kind of see where this goes. So you can also change the spawning random Pokemon from random range.0. So you don't want to constantly spawn Pokemon. So every, I'd say 25 seconds. And you should be fine. But obviously, you can keep this at 0 if you want to. So there we go. We have 2 Pokemon that spawned. And it might be a little while before the next one spawns. Well, no, not really. So you probably do want to change it to... And yeah, as you can see, it does work. But you do want to most likely change this to be around 40, so or 100. So you don't want to have to wait too long to spawn a Pokemon. But you want to wait long enough to where it's going to be fine. So yeah, guys, that is it for this tutorial. Thank you guys for watching. And this GPS system was a little bit hard to figure out, so it took me just a little bit longer than usual to make this episode. So please leave a thumbs up or subscribe. And yeah, thank you guys for watching, and I'll see you guys in the next tutorial.